Alright, so continuing on, let's talk about the atmospheric properties of Uranus and Neptune. So, like typical gas giants, they have the usual high percentage of hydrogen and helium, uh, and similar amounts 84% hydrogen and 14% helium. Uh, a bit different than Jupiter and Saturn, but maybe closer to Jupiter, a little bit different than Saturn. But they also have methane that Jupiter and Saturn have, although higher percentages, 3% for Neptune, 2% for Uranus. And what makes them different is the fact that they don't really have any appreciable amount of ammonia in the atmosphere. So first off, the methane, well, you notice that Uranus and Neptune are blue, whereas Jupiter and Saturn, do I have a picture, are, orangish, brownish, tannish in color. And um, it's the methane here that really gives them the blue colors. Methane absorbs reds and other hues of those colors and gives off what's not absorbed is blue. And you can see a higher percentage of methane for Neptune, which leads to kind of a darker blue. It's also thought that maybe there's less sunlight out this far, and so it makes it look darker. What about the ammonia? Well, ammonia freezes at some point, you know, and so it's cold enough out this far where Neptune and Uranus are, so that the ammonia in the atmosphere would freeze and probably, fall down into the lower regions of the atmosphere. So that's kind of why Uranus and Neptune are considered ice giants, as gas giants as well, Jovian planets, but the lack of ammonia really makes the methane the dominant color force anyway in the atmosphere, amongst other things. We also see bands like we saw in Jupiter and Saturn, maybe not quite as pronounced, but that could be deceiving depending on what wavelength of light you look at. As you saw in the Voyager picture of Uranus, it doesn't look like any bands at all. You had to use a Hubble Space Telescope picture, and actually I don't even know what wavelength of light this is. I wouldn't guess that this is visible, but I could be wrong about that. But anyway, you don't see bands in the Voyager picture of the flyby of Uranus, whereas you do see some bands of the Voyager picture for Neptune. But if you take an infrared image of Uranus, then suddenly you see storms and spots and bands and other things. So they're there, it's just not as prominent as Jupiter and Saturn and even Neptune. Well, another strange thing about the atmosphere of Neptune is that even though it's quite a bit farther out from the Sun, its atmosphere is slightly warmer than Uranus. It's thought that there's some sort of heat generating process going on in Neptune that isn't going on in Uranus. But just take any theories of Uranus and Neptune sort of with a grain of salt. We're able to use comparative planetology, but we just don't have a lot of data for these planets, and so maybe one of these days you guys will be studying this and send a probe that you build and design instruments on and collect some real nice data on these planets. Okay, so that's the atmosphere. What's going on deeper down inside? Well, it's current models and theories predict that it's probably a rocky core inside each of these planets. Probably maybe about 10 times the mass of the Earth, while maybe actually even being the same size as the Earth, so more dense. And they have pretty strong magnetic fields. So something strange is noticed about the magnetic fields. First off, let's look at Uranus. Remember, Uranus, its axis is tilted 98 degrees, so it goes down that way. Whereas its magnetic field is that way. North is up that way, 60 degrees off of the rotation axis. Not only that, the center of the magnetic field is way off center. Look at that. Whereas you go to Earth, they're almost aligned, just slightly off, but definitely the center of the field coincides with the center of the Earth. Same with Jupiter and Saturn. Saturn's magnetic field is perfect. Look at that, just centered, aligned, everything. Jupiter's only slightly off. So we thought that, well, this must be an artifact of maybe an earlier collision that caused Uranus to flip. Remember, back here we were like, where did this come from? Impact maybe? But then Voyager went along and looked at Neptune's magnetic field and was like, whoa, it's also way off center and tilted, not quite 60, but close to 60, 46 degrees. And Neptune isn't tilted like Uranus is. So that kind of, when you get data like that, it kind of throws you for a loop, because you have nice, neat, data that fits a certain theory, and you're like, all right, we get this, we know how this works, and then bam, something just comes and makes you realize, oh, we need more data. But to me, that's the exciting thing of science. You're always looking for better theory, and there's always something that comes along and it makes your previous theories not quite as all-inclusive as you thought they were. There's always something to be learned about science, which is great, because humans are curious and always going to try to find the next answer. If everything is answered, it'd be kind of boring. But anyway, so both planets have pretty strong magnetic fields, but they are off-axis and off-center. So one theory might be, well, maybe you have to completely discount the dynamo effect for Uranus and Neptune. Maybe that doesn't take place there, or maybe it does take place, but then there's something else going on in the atmosphere that that combines with the dynamo effect magnetic field to produce this newer, like, displaced magnetic field. And if you've taken physics, when you add vectors, you get a magnitude of two vectors, the vector sum. So magnetic field you can represent with vectors as well, and so maybe it's a vector sum. Who knows? We really don't have enough data to go on. So another interesting problem to be solved in the future. And Uranus and Neptune have some fun moons. Now let's quickly take a look at this. Well, first off, Uranus, as of this last year, has 27 confirmed moons, four of which are the largest, four of which are sort of medium-sized moons, and that's these four here. Miranda's, I would say, is considered a small moon. Neptune has 13 moons as of 2013, and they're all small moons except for Triton, which is considered one of the larger moons in the solar system. So just to compare, here's our moon, kind of one of the bigger moons in the solar system, but definitely not the biggest. Jupiter and Saturn have that award. Jupiter has four really big moons, and Saturn has really just one big moon and a bunch of medium-sized moons and some small moons. Uranus, like I said, has four sort of medium-sized moons, and then a bunch of small. The rest are small, if not tiny, like Puck here. And then Neptune has a bunch of small moons, no really medium-sized moons, and then one big moon, Triton. And Triton's kind of a cool moon for a bunch of reasons, and I already alluded to one when we looked at eyes in the solar system in the last video. And also to compare, this is the size of the Earth. So some of the moons in our solar system are pretty big. Pluto's moon, Charon, is actually it competes pretty well with some of the medium-sized moons. So. And really the only moon I want to talk about is Triton. So let's talk about that. So Triton is really the only large moon in the solar system to orbit retrograde. So that's what you saw in eyes in the solar system, is Triton was orbiting backwards in opposite the direction that just about every other moon orbits around its planet. Weird. How did that happen? Yeah, don't know. It's kind of big to be captured, although Neptune is pretty big, so maybe it has the ability to capture a moon that big. We've been talking about the capture theory for our moon and our Earth is kind of tiny, so maybe it worked for Neptune. Who knows? The surface temperature of Triton is cold, only 37 degrees above absolute zero. That's cold. Can't get lower than zero as far as we know. So yeah, it's really cold. It looks like it has a very thin, tenuous nitrogen atmosphere, which, if you remember, Earth's atmosphere is mostly nitrogen, but this is a very thin atmosphere, not too much to brag about. And probably it has water ice on the surface, amongst other things. So it might be a fun place to visit at some point in the future. It would be, again, it'd be really cold. I wouldn't necessarily think we would settle there anytime soon without some crazy, super awesome futuristic technology, but it might be fun to visit, at least send a probe and explore. So, and I think, yeah, that's it. So that's it for Uranus and Neptune. I'm going to do a brief little video on Pluto, although we don't know a lot about Pluto. We're sending a new probe there that should get there in 2015. I'll talk about that in the Pluto video. But you know, unfortunately, you guys are taking this class a couple years too early to really get all the good stuff about Pluto. But you can keep in touch with the news, and I'm sure it's going to be a big deal when New Horizons gets there. And so check it out when it happens. All right, talk to you later.